Okay, please begin by writing your name on top. And call this Classwork 40, CW 40. We're going to be constructing the various centers of a triangle today. Give me the name of one of our centers, please. Sounds great. On the top right-hand block here, I'd like you to write Circumcenter. Now we know that the circumcenter is formed by making what segments? Good. Perpendicular bisectors. So in the top left-hand block here, we're all going to draw a triangle. And as a pro tip, if you draw the triangle in ink, you're able to then erase later if you make mistakes and you don't have to redraw the triangle. No, draw the triangle in ink so that when you do the construction tools in pencil, you'll be able to erase the construction mistakes and still have the triangle there. So I draw this part in pen, and then I'll do the perpendicular bisector with pencil. Your triangle can be any triangle. What are the features of a perpendicular bisector? How do I draw it? I'm going to find the middle point here, and I need to go up perpendicular to it. In terms of constructions, we have a skill that we've used many times to do this. You may remember we put the needle on the end, and how far do we open this? Good, a little more than halfway, and then you make an arc. Pick that same length up, move to the opposite corner or vertex, and draw another arc. By doing that, we should produce this football-looking thing. And if we now connect the endpoints of this football, we produce a line that is both perpendicular and a bisector. How did I do with mine? Scale of 1 to 10, would you say that is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? It's a little off, isn't it? Maybe an 8? I think my curves were really good. They're nice and smooth, but I kind of missed here, didn't I? On the bottom and on the top. I didn't draw my line as well as I could have. It's going to be a little bit off. And if we're not precise doing this, when we do the circumcenter, we're going to miss and it won't work out, because what should happen with all three perpendicular bisectors? They should meet at a single point. So if I make mistakes in my perpendicular bisectors, they won't meet at that single point. Okay, so let's move now over to the circumcenter side. And again, use a pen to draw a triangle of some sort. Yours does not have to look like mine. And now we're going to construct perpendicular bisectors to all three sides. I'm going to do my bottom side first. So from this end, I go more than halfway. Make an arc. Same from the other end. Make an arc. Then I'm going to use my football. And I always like this trick to try to do a little bit better. It's easier for me to put my pen on that point of intersection first. and then move my straight edge up to the page. And I can usually do a better job of hitting the little points by doing it that way. And mark that it's perpendicular and a bisector. Do that on all three sides. Turn the page, do it again. All right, so I've got my first perpendicular bisector. I'm now going to draw my second one. Mark that it's perpendicular and a bisector. Did I draw these long enough? How do I know? Because they're meeting. Where do I expect the third one's going to go? Through that same point. So theoretically, you don't need to draw three, do you? No, the only reason to draw three is to what? Check, make sure, right? Verify that you did it correctly. So let's try the third one and see how I did. Probably. Because that's the easiest way for me to check. Hey, how'd I do? Not bad, right? It's a little missed. So that's one way to check it, is to see if they all meet in the same point. But I could still actually have made them meet in the same point, but it's the wrong point. I'm claiming this is a circumcenter. What's the superpower of a circumcenter? Same distance from all vertices. It's equidistant from all vertices. So if I were to stick my needle here at what I think is the intersection and measure using my compass to one of the vertices, I expect that if I draw a circle with that as my radius, what will happen? It'll pass through all three vertices. In other words, all three vertices will be on the circle. Please stop the side conversations. So on yours, I'd like you to construct the circumcenter as I did, and then use your compass to make a circle through one of the vertices, and let's see if it covers through the other ones as well. I'll circulate around and see how it looks. As I just circulated the room, I found lots of people with really good solutions. One clever student noticed that mine looks different than theirs. She said, I must have done it wrong because my center falls inside the triangle. Yours is outside the triangle. How many of you have it outside the triangle like mine? 1, 2, 3, 4, 5, 6, 7, 8. How many of you have it inside the triangle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So more that way. Well, I don't have a... What's the difference? Different triangles. Okay, give me more specifics. Yeah. My triangle is obtuse. Everybody who has their mark outside the triangle, is your triangle also obtuse? Raise your hand. Does anybody have an acute triangle with the circumcenter outside? Does anybody have an obtuse triangle with the circumcenter inside? Nope. Okay, so that's a pretty good conjecture, isn't it? That if the triangle is obtuse, it'll fall outside the triangle, because that's the only place it can be equidistant. If it's acute, it'll fall inside. What do you think will happen on a right triangle? It'll be on the hypotenuse. Good. Okay, questions on the circumcenter or perpendicular bisector? 5, I feel comfortable constructing a circumcenter from scratch. 3, if I look at these notes, I'll be able to reproduce it. 1, I can't do it at all. Strong scores. Excellent. Let's move on, please, to the second one. What's another center we'd like to build? Good. Incenter. And the incenter is formed by making three whats? Good. Angle bisectors. So let's give ourselves a triangle. This triangle won't matter if it's acute or obtuse. It's only the circumcenter that has that cool feature. All the rest of these centers will be in the triangle on the interior. Now we're going to end up bisecting all three of them over here. We're just going to do an example of an angle bisector for now. I've colored the left vertex. That's the one I'm going to bisect. Do you remember how to do this? First, we need a reference arc. So put your needle on that vertex, set your compass to any length you want, make an arc. And what you've just done is confirmed that this point and this point are equally distant from the vertex. In other words, I made myself a nice isosceles triangle here. We remember from our isosceles triangle theorem that if I bisect the base and go up the top, that's the same center that we use to make the isosceles triangle theorem. In other words, it's an angle bisector, it's a median, it's an altitude, and it's a perpendicular bisector. So we're going to pretend that there's a segment between these two things and do exactly this skill that we did before. I'm going to go from one endpoint, and I'm going to go more than halfway to the other dot, make an arc, and then move over to the other dot with the same size setting on my compass and make my little football. And if I connect the endpoints of my football, they should go right through what other point? The vertex, right? The corner of the angle. And this is a good double check. Why? 3 points are always, sometimes, or never collinear. Sometimes. So if these three turn out to be collinear, I've done it right. It's possible they could turn out to be non-collinear, in which case I've done it wrong. Let's show that we've made this an angle bisector by leaving marks in here to show that that angle has been bisected. Sometimes it's helpful to label your picture in a way that tells you, reminds you later how to do this. Like, for example, say 1, this is what we do first. 2, this is what we do second. 3, this is what we do third. 4 is to draw the angle bisector. All right, let's now build the incenter, which is the same thing, just done to all three angles. And we're going to be getting a lot of marks on the page, so you've got to keep track of what you're doing. I'd say I did about an 8 job again. It's not like it makes a big triangle in there, but instead of a point, it's making a triangle in there. How's it working? 5, I'm done. 3, it's working. I'm just need a little more time. 1, I need some help. Okay, good. I'm going to pause for a second. All right, so after circulating, it's clear that people have a really good shot at this. How do we know if it's right? How can we check? Because what is the superpower of an incenter? Equidistant from all 3 sides. So how do I measure the distance from a point to a side? Right, but my question is, do you agree that if I go from this point and I want to measure to this side, I could measure, now I'm using a ruler right now, which I'm not allowed to do. That suggests it's 1 inch. Is that how far this line is from this point? Is it that measurement? So it's like 7/8. Good. It has to be perpendicular because that's the shortest distance. So we can't do that right now. Yeah, there's a way to do that. But what we're going to do is we're just going to say, I'm going to find this center, put my needle on the incenter, and I'm going to adjust my compass until it's like, as I swing by, it just barely kisses the side. The term is that it's tangent to the circle. The side is just barely touching it, make a full circle going through the inside of this shape. And if you did it correctly, the distance to each side would be the same. Again, because I didn't do mine quite right, what happened over here? There's a gap there. There really shouldn't be a gap. It should be touching every side. So this is an imprecise one. It's probably an 8 out of 10. But the idea is certainly shown there. So you guys please draw that inner circle as well to see how carefully and completely you did it. The building of an incenter. Yep, it's about what mine did, which is reasonable, right? But maybe if this is the tool that's going to get you off a desert island and save your life, you might want to be more careful. All right, please flip the page. Top left corner and top right corner, we are going to construct the 3rd center, which is called the what? Centroid. And the centroid is formed by making 3 whats? Medians. So draw yourself a triangle in the left one. Let's draw a median. What is a median? Good. We're going to take the middle of one of the lines, one of the sides, and draw that straight through to a vertex. So in other words, I need to find the midpoint here and then connect that to the vertex. Do you guys know how to find the midpoint of a side using construction techniques? The football, right? We can do the perpendicular bisector, and we won't use the perpendicular part. We'll just use the bisector part. So I'm going to use my longest side here. Needle on the corner, more than halfway. Make an arc. Same from the opposite corner. I get my football. And again, while this actually produces a big line, I'm not interested in the whole line. All I care about is the midpoint. I just want to show where it breaks this side in half. And I think it's a good idea to show that it's a bisector. In other words, that we've cut it into two congruent segments. Okay, to make the actual median, I need to connect this midpoint with this opposite vertex. That green line segment is my median. I'm going from a vertex to the midpoint of the opposite side. And let's draw a centroid, construct a centroid, which means 3 of those. Now, I have a little pro tip for you. You know how we end up with a whole bunch of competing pencil marks and it's hard to kind of see what's going on? I need to basically bisect all 3 of these sides. Right. Choose the biggest leg and set it up for that. In other words, from this corner, go more than halfway on the biggest leg. And I'm just going to make it cross over both of these sides. Then I'll come back to this leg, draw that same arc, cutting over both sides. And then from this one, doing the same thing. I didn't quite make this one far enough. So what you'll see, if I did this correctly, is that I've got one football here, one football here, and one football here. So use those to find the midpoint. And again, we're just using this to find the midpoints of the sides, not the whole perpendicular bisectors. Notice how I made my perpendicular bisectors dotted. If I hadn't made them dotted, if I made them solid, they would meet in one point. What's that point? The circumcenter, right? We don't want to confuse things, so that's why I didn't make them solid lines. All we care about is connecting each midpoint to the opposing vertex.
You need to take any.
That's right. That's a protractor. That's better than an 8, isn't it? What would you guys give me on that one out of 10? That's pretty close to a 10, isn't it? We haven't tested it yet, but they all meet at the same point. That's my best one so far. All right, let me walk around, make sure you're good with this. Then I'll come back and talk about how we test it. Hey, as I walked around, somebody made an insightful comment about what happens if this becomes too much like an equilateral triangle. Is mine pretty close to an equilateral triangle? Pretty close. If in fact it were truly equilateral, what would happen? Remember how we identified that the 3 dotted lines right here would make my centroid? Excuse me, circumcenter, right? And this is my centroid. If in fact this were a perfectly equilateral triangle, what would be true about the centroid and the circumcenter? They'd be on the same spot. Okay, so we try to avoid that because then we don't really know if we made a mistake. All right, what is the superpower of a centroid? There's 2 of them. Center of balance. So if I wanted to cut this out of cardboard and then like balance it on my finger, that would be the spot I'd need to do it on. That's kind of unrealistic for what we're doing right here. What's the other? Yeah. Excellent. It splits each median into a 2-to-1 ratio. So here's what I'd like you to do. Stick your needle at your centroid and measure to one of the midpoints. I'm going to choose this one. And then spin it around and make an arc through the other part of that same median. In other words, I'm seeing if this length goes to there, and then I pick my compass up, put it right on there, and I'm showing that this length and this length are each the same as this, so that it's a 1-to-2 ratio. So I'm going to measure from my centroid, adjust the compass to get exactly what the length of my semi-median is, my partial median here. Turn it around to make an arc on the other part, my longer part of the median, and then carry that up to here, and it should go right through that endpoint, confirming that this part is 2 parts to this is 1 part. And again, if it's not quite right, see if you can identify where your mistakes might have been. What's the last center we're going to deal with? Orthocenter. And the orthocenter is formed by making what? Altitudes. I'm going to let you guys play with this for a minute. You do it. Go. All right. As I circulated around, I found a number of people struggling with this. Just finding the altitude is hard. But let's do this one first. If I want to find the altitude here, what I'm looking for is something that goes through this point and goes straight down perpendicular. Now, if I happen to have constructed isosceles, that's going to be the same line as if it was an angle bisector or perpendicular bisector, goes to the midpoint, so it's a median, all those the same. But let's assume it's not a perpendicular bisector, it's not an isosceles triangle. What I need to do is just like we did on homework 21, we're going to construct a line that is perpendicular to this, but not through the midpoint, instead through this point off the line. And so if I put my needle there, first thing I'm going to do is extend my compass so that I can cross over my opposite side in 2 places. These 2 points now become the points from which I'll do my football because those are equidistant. So now I've forced this to be an isosceles triangle. More than halfway. Hold on, let me pull this up. Same from here. And if I did this correctly, it should not only be perpendicular, but actually go right through that vertex there as well. And I expect that that's going to be perpendicular and through that point, not a bisector. Now, it has to go through the vertex. If it doesn't, you made a mistake. But that's what this does, right? If we go arc here, we find 2 points that are equidistant, so that from those 2 points, it's right up the middle of the isosceles triangle. Now, how would you do that if I was trying to do it from this point here? Because the first thing to do is to draw an arc that cuts across the bottom in 2 places. Hold on. Right? So what I would have to do is extend artificially this base. Right? That's still like the ground level. And so now I'm going to go from this point, cutting across. Oop, that's still too much. There we go. So I know that this point and this point are equidistant from this, that opposite vertex. So if I go more than halfway there, and the same from over here, I should be able to produce a perpendicular segment that is going right to the vertex. And that should be perpendicular. Do you remember when you guys did the area of triangles in, I don't know what grade that was, 3rd or 4th grade or something? And if you want to find the area of a triangle like this, you had to find this base times this height, perpendicular one, divided by 2. Okay. Last piece of classwork is for you to create the orthocenter doing all 3 altitudes. Make sure that yours continue. Notice that I stopped mine here. That's not going to work. You need them to go far enough that they're actually going to meet. And what's the special superpower? There is no superpower. Orthocenter is something of interest in 9-point circle, the Euler line, but not for us. Your homework tonight is to do what? Same thing. Up there, write HW40 and do exactly the same skills. That'll be homework number 40. Thank you.